The next thing I'd like to look at is what's called Taylor polynomial. So recall that the Maclaurin polynomial is centered at x sub 0 is equal to 0. And the Taylor polynomial extends that, and so the center can be anywhere. So here's the definition of a Taylor polynomial. If f can be differentiated n times at x sub 0, then we define the nth Taylor polynomial for f about x equals x sub 0 to be the polynomial p sub n of x is equal to f of x sub 0 plus f prime of x sub 0. And here is where it's different. It used to be just x, but now it's x minus that new center. So in the Maclaurin polynomial, all of these x sub 0s were zeros, but now they could be any other number. So the format on this is pretty much similar for this portion, except when you are squaring it, you have to take x and then subtract off whatever that new center is. So the nth term polynomial on this is f of, and then whatever the power of the derivative of n is, of x sub 0 all over n factorial times x minus, and then that center x sub 0 raised to the nth power. The Maclaurin polynomials are special cases of the Taylor polynomial in which x sub 0 is equal to 0. Thus, theorems about Taylor polynomials can also apply to Maclaurin polynomials. Okay, so I'd like to take a look at now the function natural log of x, and we're going to have the center at x equals 2. Okay, so that's the new center instead of 0. So I'll first of all write down the original function f of x is equal to the natural log of x, and then I'll take the 1, 2, 3 derivatives beyond that. So f prime of x is equal to 1 over x, f double prime is negative 1 over x squared, and f triple prime of x is equal to 2 over x cubed. So when I find the values at 2 for each one of them, f of 2 is equal to the natural log of 2, f prime of 2 is equal to 1/2, f double prime of 2 is equal to negative 1/4, and f triple prime of 2 is equal to 1/4. Okay, so now I'll write out the polynomial for each one of them. So p sub 0 of x is the same thing as f of 2, which is equal to the natural log of 2. Then the first order Taylor polynomial would be p sub 1 of x is equal to f of 2 plus f prime of 2, and then I take x minus 2. Okay, so this is where it's slightly different from the Maclaurin polynomial because the center is not at 0, but it's at 2 now. And so you end up with the natural log of 2 plus 1/2 x minus 2. Then the second order Taylor polynomial is f of 2 plus f prime of 2 times x minus 2 plus f double prime of 2 all over 2 factorial times x minus 2 squared. So then when I make that substitution, I get the natural log of 2 plus 1/2 x minus 2 minus 1/8 x minus 2 raised to the second power. And then my final one is the third order Taylor polynomial is p sub 3 of x is equal to f of 2 plus f prime of 2 times x minus 2 plus f double prime of 2 all over 2 factorial times x minus 2 squared plus f triple prime of 2 all over 3 factorial times x minus 2 cubed. And then I'll substitute the values in, and I get natural log of 2 plus 1/2 x minus 2 minus 1/8 x minus 2 squared plus 1 over 24 x minus 2 cubed. Okay, so I'd like to show you this on the calculator. All right, so I actually put in the natural log graph, so let's just take a look at that one first. So here is the ln of x, and then I'll just take it in steps here. So I'm looking at, first of all, let me just clear this part. Okay, so for the p sub 0 is the natural log of 2. So this time you're looking at it at x equals 2 and not at x is equal to 0. So there is your graph. So if you look at where 2 is, natural log of 2, 1, 2, so that's going to be here, and okay, so now let's take a look at natural log of 2 at 2, and then I'm going to add on, let's see, where am I here? Okay, now I'm going to do this one right here. So then that'll be plus quantity x minus 2 divided by 2. Okay, so you can see at 2, this is a little bit better approximation. So you're not looking at 0, but you're looking at 2. So that will be this one right here. And then I'll put in one more. So I'm going to do the second order Taylor polynomial. So now I'm going to be subtracting quantity x minus 2 to the second power and divided by 8. Okay, so let's take a look at that one. And now you can see that it's getting even a little bit better. All right, so I'm not going to show you the third order, but it'll get even better than that. So in general, for Taylor polynomials, it'll be perfect at that center. So in this case, at 2, it's going to be perfect. And then after that, if it gets farther away from the center, then the approximation is going to get worse. And as you add more terms, the approximation gets better. Okay, let's go to page 5. And now I'd like to look at writing the sigma notation for Taylor and Maclaurin polynomials. Frequently, we want to express the formula for Taylor and Maclaurin polynomials in sigma notation. To do this, we use the notation f, and then this is actually the derivative, kth derivative of x sub 0, to denote the kth derivative of f at x equals x sub 0. So the Taylor polynomial in sigma notation would be written this way. The summation of f of the kth polynomial or derivative of x sub 0 divided by k factorial, and then you're multiplying it by x minus x sub 0 raised to the k power as k equals 0 out to n. So this is the first n. And so then this is the 0th order, first order, second order, third order, all the way to the nth order. For the Maclaurin polynomial, your x sub 0 is just going to be 0. So then you get the summation of f of k of 0 times x to the k power all over k factorial as k equals 0 out to n. So that gives us f of 0 over 0 factorial plus f prime of 0 over x over 1 factorial all the way out to f of the nth derivative of 0 times x to the nth power all over n factorial. Okay, so let's take a look at the nth Maclaurin polynomial for 1 over 1 minus x, and then we're going to express it in the sigma notation. Okay, so my original one is f of x is equal to 1 over 1 minus x, and then I'm going to take 4 derivatives first. All right, so f prime of x is equal to 1 over 1 minus x squared, and then f double prime of x is equal to 2 over 1 minus x cubed. F triple prime of x is equal to 3 times 2 over 1 minus x raised to the 4th power. And then the 4th derivative of x is equal to 4 times 3 times 2. And I'm intentionally writing this numerator without multiplying it out so that you can see a pattern. So when you write the nth polynomial as a sigma notation, you need to be able to see the pattern on these. So now when I evaluate it at 0, f of 0 is equal to 1, which is equivalent to 0 factorial. F prime of 0 is equal to 1, which is the same as 1 factorial. F double prime of 0 is equal to 2, which is equal to 2 factorial. F triple prime of 0 is equal to 3 times 2 and that's equal to 3 factorial. And f fourth derivative of 0 is equal to 4 times 3 times 2, which is equal to 4 factorial. Okay, so now I'm ready to write the last or the final term on this. So f of the kth derivative of x is equal to, and so you can see that in all these patterns here, it's going to be k factorial, and then in the denominator, it's 1 minus x raised to the k plus 1. And so the f of the kth derivative of 0 comes out to k factorial. All right, now I'm going to write the sigma notation. So substitute in f of the kth derivative of 0 and make that equal to k factorial into the Maclaurin polynomial, and that yields the nth Maclaurin polynomial for 1 over 1 minus x. All right, so that's what this next line is going to be. So I have the summation of the f of the kth derivative of 0 times x to the k all over k factorial. So now in place of this right here, I'm going to put in the k factorial. And so the k factorials just cancel out. And then I'm left with summation of x to the k as k equals 0 out to n. And that is equal to 1 plus x squared plus all the way to x to the nth power. So this is the beginning term, and this is the final term. And this is where n is equal to 0, 1, 2, and so on. Okay, let's do one more example. So this is on page 6. So in example 5, it says to find the nth Taylor polynomial for 1 over x about x is equal to 1, and you want to express it in sigma notation. So I'm going to write out the first 1, 2, 3, 3 derivatives. So I have f of x is equal to 1 over x, and then f prime of x is equal to negative 1 over x squared. F double prime of x is equal to 2 times 1 over x to the third. F triple prime of x is equal to 3 times 2 over x to the fourth, and that's negative. So when I calculate it at 1, f of 1 is equal to 1, which is 0 factorial. F prime of 1 is equal to negative 1, and I can write that as negative and then 1 factorial. F double prime of 1 is equal to 2, which is equal to 2 factorial. And f triple prime of 1 is equal to negative 3 factorial. So you can see that the signs are alternating. So for the f of the kth derivative of x, I can write it as f of the kth derivative of x of 1, and that is equal to, so the signs are alternating, and since it is starting with a positive, I'll write it as negative 1 raised to the k power, and then of k factorial. Okay, so now I'm going to substitute in f of the kth derivative of 1 and make it that equal to negative 1 to the k power times k factorial into the Taylor polynomial with x sub 0 equaling 1. So that gives me a summation of f of k of kth derivative of 1 of x minus 1 to the k power all over k factorial. So now in place of this right here, I'm putting in this. So that gives me negative 1 to the k power, and then k factorial here, and this k factorial will just cancel out, so that I'm left with x minus 1 raised to the k power. And so I end up with the summation of negative 1 raised to the k times x minus 1 to the k power as k equals 0 out to n. And if I were to write it out, this is what it would look like. I have 1 minus quantity x minus 1, and then all the way out to my nth term, which is a negative 1 to the nth power, and x minus 1 to the nth. Okay, so there are about 4 of the Maclaurin polynomials that you should memorize. So let me show those to you. Okay, so you should write this down somewhere on paper. These are important Maclaurin polynomials, and when I say Maclaurin polynomials, it's the same thing as saying Taylor polynomials centered at x sub 0 is equal to 0. Okay, so that is the same thing. So the first one that you should be familiar with is e to the x. Okay, so e to the x, the sigma notation is x to the k power all over k factorial as k equals 0 out to n. So when you expand that, it's 1 plus x squared over 2 plus x cubed over 3 factorial plus x to the 4th over 4 factorial all the way to x to the nth over n factorial. Okay, and we actually derived this in another part of the lesson. The next one that you should be familiar with is the sine of x. So for the sine of x, it's an alternating sign, so you have a -1 raised to the k power. And just remember that sine is an odd function. So in order to create odd powers, you have to do x raised to the 2k plus 1 all over 2k plus 1 factorial. And so then if you expand it out to n terms, it'll be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial all the way to the nth term. And that will be -1 to the nth times x to the 2n plus 1 all over 2n plus 1 factorial. Okay, the third important one is the cosine. And so for the cosine, this is also alternating, so you'll have a -1 raised to the k power. And then since cosine is an even function, you'll take x and raise it to the 2k power all over 2k factorial. And this would be the expansion. 1 minus x squared over 2 plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial all the way to -1 to the nth times x to the 2n all over 2n factorial. Okay, the final one that you should be familiar with is 1 over 1 minus x. And so this one is, the general is x to the k power. And this will be 1 plus x squared plus x to the 3rd plus all the way out to x to the nth power. And this one is very similar to the geometric sum. So this is similar to the geometric sum. And if you recall, the geometric sum is equal to, S is equal to A over 1 minus R. So in this case, it's going to be similar to 1 over 1 minus x. So the first term is A, and then your common difference is, or common ratio is x. So that will be your R. All right, so that's a good way to remember it for the 1 over 1 minus x.